Alright, so yesterday we talked about a bunch of stuff relating to perpendicular lines, right? Like there was like 5 theorems, and then the distance between a point and a line, and then 2 parallel lines we kind of talked about. So number 1 says to find the measure of angle 3, and in this diagram they give you that there's a right angle here, and then they give you that this is 72. So what else can you determine from this graph?
Vertical angle.
There's a vertical angle, which means that this is 72, then this must be 72, right? What else do you know from this graph? If this one's a right angle, then this one's a right angle, which tells you these two add up to what? 90, and I can subtract the 72 away from it to get 18. Okay, should be 18 degrees. Number 2 says, how do you know that A and B are parallel? So what did you write?
If C and D are parallel, then A and C are perpendicular, and then A and C.
So you're trying to prove they're parallel, so you can't use that they're parallel yet.
I said if A and C are perpendicular.
Wait, do you say? I'm confused.
Okay, so the actual wording, the actual wording would be if 2 lines are perpendicular to the same line, then they are parallel. Okay? Gio, I think you said corresponding. I would give you that too, because they're 90, then they're corresponding. It's just that if you're going to use that in a proof, you have to do a lot more steps. But yes, if A is perpendicular, yeah. So in generic terms, it's if 2 lines are perpendicular to the same line. Okay. If you write specifically if A is perpendicular to C and B is perpendicular to C, then that's the same thing. You're just using the example that's here. That's fine. So if 2 lines, which in this case are A and B, are perpendicular to the same line, which in this case is C, then they are parallel. Okay? Again, you could have also gotten there using corresponding. It just means a little bit of extra work. All right, so 3 says find the distance between the 2 parallel lines. First of all, this is similar to kind of what we did yesterday, and then there's a little bit more in the homework. We're kind of going to put them all together, but the same type of problem. In order to find distance, I need to find what? What shows true distance? A perpendicular segment, right? So when you look at these graphs, first of all, you already know they're parallel, but perpendicular might be here. I'd need to know this is a right angle, or it might be here. I'd need to know that's a right angle. So how do you know if it's perpendicular if you're given the points?
You get the slope form.
Good. I need the slope form, and I could do it a lot of different ways. But let's say I want to say that this is perpendicular to this line. Then I'm going to find the slope of this line, and then I'm going to find the slope of this line and show that they're perpendicular. So to do that, the slope of this first line here would be -1 minus 4 over -4 minus 0, and I get -5 over -4, or 5/4. So that's the slope of that line. And then I also want to find the slope of this line here. So I'm going to use the 4, -4, -1, and the 1, -5. So I get -5 minus a -1 or +1 over 1 minus a -4 or +4. And I get -4 over 5. Now when I'm comparing these, how do I know that they're perpendicular? Opposite reciprocal. So these are perpendicular, which means now I can find the distance between this point and this point. So I'm going to use the distance formula, which is D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And my 2 points are 0, 4, and -4, -1. Plug them in, and I get the square root of -4 minus 0 squared plus -1 minus 4 squared, -4 squared, -5 squared, 16, 25, 41. Wait, what? Fight, what? Shh, you guys need to relax. Michaela. Shh.
I don't understand why we couldn't do that. Why we couldn't just use the distance formula right away.
Because if it's not perpendicular, then it's not true distance.
So what do we know?
Wait, guys, hang tight. If that segment, so let's say they give you 2 segments, which is kind of like what we did yesterday's example. There was 2 segments. One was perpendicular, one wasn't. So unless you're 100% sure that it's perpendicular, you cannot use that as distance. distance has to be perpendicular. Does that make sense? So you're first showing that it's perpendicular, which means that it would be the right one to use. In this case, both were perpendicular, so you could have used either one, but that doesn't necessarily always happen. The one that we did yesterday, it didn't happen, okay? So then when I'm not done though, because when I get to this point, I want to make sure this can't reduce, right? 41 is prime, so I'm going to leave it like that. But remember, if it was able to be reduced, I would. I'm not going to round it. I'm going to keep it exact, which is exactly what that is. Lewis.
So you didn't get the opposite number?
If you didn't get an opposite reciprocal, then you would know you can't use that segment.
And if you didn't, you would use the...
If hopefully the other one would be.
Yeah, but how would you use the other one? Would you...
Same thing. I would test to see if this is perpendicular to this. So I would test this slope versus this slope. We already have one. And then if that's opposite, I have to give you something that would give you perpendicular.
Negative 4 over 5 is the first one? That's
Was the slope of the bottom line, this one. That's this one. The 4, -1, and 1, -5. Yeah. Okay. Oh, sorry. Okay, this, starting with the homework. So this is actually the last ones. These are the quiz ones, right? It says write an equation of the line that passes through point P and is parallel to the line with the given equation. So I'll do one from each of these sections because they're repetitive. This one says parallel. So it's going to pass through, I'm going to pick this one. It's going to pass through this point, but it's parallel to this line. So if it's parallel to y minus 8 equals 2x plus 10, what do I need from that equation?
That's slope.
Just its slope. So you can even put the 8 to the other side, although it doesn't matter because it's just affecting the y-intercept. Okay? But we've solved it for y. The slope of this line is what? 2. So what's the slope of a line that is parallel to this?
The same.
Same. So it's 2. Then you've got your point, which is -5, -6. Now, remember, we've gone through this a bunch of times. You can either use slope-intercept or you can use point-slope. Okay, I'm going to use point slope. Y minus y1 equals m times x minus x1. This is my x1, y1, and this is my slope. So y minus a -6 becomes plus 6. 2x minus a -5 becomes plus 5. Distribute the 2. Subtract the 6.
Subtracted wrong again.
You did again? Get it all out now before you take a test.
Change the math.
Sure. Okay, so it's the same for this and this. You need the slopes of those lines, and then you plug in the slope and the point. So what's different about 3? What is an x equals 15? What kind of line is that?
Wait, what?
X equals 15. What kind of line is that?
1 equals true.
It is definitely a straight line. That's very specific. Yes. What kind? Huh? What kind of line is it? A vertical line. Thank you, Kelly. And if it's a vertical line, it has what slope? Undefined. So I can't plug that in, but what I do grab is x equals, and I grab the x, which is 1. There is no work that can be done to find that. You have to know that. There's no plugging in of the word undefined and then solving for it. You have to know the vertical line is undefined and it's an x equals. And then you have to know a horizontal line has slope of 0 and it's a y equals. Okay, so then 4, 5, and 6, the instructions change to say write the equation of the line that passes through point P is perpendicular to the line with a given point. So what's the difference between 1, 2, and 3 and 4, 5, and 6? Good. Perpendicular means that once I find the slope of the given line, I have to find the opposite reciprocal. So if I grab this first one, if the line that it's perpendicular to is 2x minus 1, my slope is 2, which means a perpendicular line would have slope that is what? -1/2. And then I'm going to use this point, 3, 4, and this slope. So y minus 4 equals -1/2, x minus 3, y minus 4 equals -1/2 x plus 3/2. And then, God bless you, that time it was a sneeze, right? And then y equals -1/2 x. This is over 1. I have to give them the same denominator. So now I'm adding 3 over 2 and 8 over 2. Good. 11 over 2. Hurry. All right, 31 says proving theorem 3.8. So here's your partially filled in. Remember, this test is not going to be partially filled in. This test is going to be open. So given that 1 and 2 are a linear pair and that angle 1 equals angle 2, you're trying to prove that they're perpendicular. The good news is if I gave you this proof, okay, without the actual steps. You could go straight from the given to the proof based on the theorem that we talked about yesterday. That if two angles that are a linear pair are congruent, they have to be perpendicular, okay? So this is the long way around. It says 1 and 2 are a linear pair. That's given from your diagram, and it's also given in your statement. 1 and 2 are supplementary would be the definition of a linear pair, or linear pair postulate, which can be the same thing. So if you put definition of linear pair, I would have given it to you. Okay, they basically are the same thing. Michaela.
So on the test, if like you have all these steps, where do we just write?
You could
down-
literally write the given and the proof, but it won't be that easy. Yeah. Number 3 says the definition of supplementary angles. So I know that if I'm switching from supplementary to what it equals using its definition, then that should be equals 180. Number 4 is again given. Number 5, the measure of angle 1 is equal to measure of angle 2. That's the definition of congruent angles. We went from congruent to equals. Number 6 is substitution property of equality, because instead of saying that 1 plus 2 equals 180, we said 1 plus 1 equals 180. Number 7 is 2 times the measure of angle 1 equals 180. That's combining like terms. You can also say simplifying. Okay, I would have taken either one, but that time it was given to you. Number 8, I'm going from the measure of angle 1 equals 180, or sorry, 2 times the measure of angle 1 equals 180 to measure of angle 1 equals 90. That's division property. Then I'm going from 90 to something involving a right angle. You've replaced the word, or you've replaced 90 with a right angle, which is the definition of the right angle. And then if it's a right angle, then they're perpendicular, and that's the definition of perpendicular. If this was a proof, which it won't be, I want to be really clear, it's not going to be this easy. You could go from the given, and you could go to the proof, and you could say if two adjacent, or two angles form a linear pair and are congruent, then the lines are perpendicular. So that was one of the theorems that we used yesterday. All right, this one says, draw the quadrilateral ABCD with the coordinates, blah, 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 blah. Find the distance between each pair of parallel sides of A, B, C, D, and round to the nearest tenth if necessary. So I'll bring in a graph. And I'm going to plot these points. -4, 1, -4, -1. B, 2, 3. C, 7, 2. D, 1, -2. Okay, so to figure out which sides are parallel, I would need to know the slopes of the lines. So if I do the slope of this line and this line first, then I'm going to use, here, let me label these points. A, -4, -1, 2, 3, 7, 2, D, 1, -2. I can either plug those points in, or I can actually count rise over run. So I can go up 1, 2, 3, 4, right 1, 2, 3, 4, 5, 6. So the slope of that side is 4/6 or 2/3. And then I can count the other side. Okay, I can go up 1, 2, 3, 4. That's 4 again, right? 1, 2, 3, 4, 5, 6. That's 6. That's 4/6 again, 2/3. So I know these are parallel. Now I've got to figure out where it would be perpendicular. So if it is parallel at 2/3, where is it perpendicular? If the slope of it parallel is 2/3, perpendicular would be? -3/2. Okay? So let's see if we could find a point in which we can already, because these are definitely not perpendicular. These are definitely not perpendicular, right? But if I go here and I go -3/2, there's no point there, okay? If I go here, 1, 2, 3, 1, 2, there's a point there. So I know that this, wait, did I go -3/2? Down 3/2. This is a really, this should be perpendicular, okay? Because again, I reversed the slope. So this now tells me I have this point, which was my 2, 3, and this point, which clearly passes through, is 4, 0. So it was not one of the ones that was originally given to me, but I found it by the perpendicular slope. So now I want to find the distance between those 2 points. So I'm going to use 2, 3, and 4, 0, and I get the square root of 4 minus 2 squared plus 0 minus 3 squared, 2 squared plus negative 3 squared, 4 plus 9, which is the square root 13. And you're going to leave it like that. You're not going to estimate it. So you have to figure out what are parallel unless they tell you that they're parallel, which is like the next example. And then you have to find a way to find a perpendicular point.
It says round to the nearest 10.
Right, but your test won't. So you want to keep it exact. Your test will say keep it exact. If it can be reduced, so if it was 20, root 20, I'd break it down in the factor tree, reduce it. But if it's a square root that can't be reduced, it keeps the way it is.
Like, how do we know, like, that's perpendicular? How do we just see that?
You can use your, well, I use the slope. So I took the slope, right? Because clearly there's nothing that's already there that's perpendicular. So then I use the slope and I reverse it, change the sign, and then go from each point and see if you can find a point that is that based on the reciprocal, opposite reciprocal.
The reciprocals are opposite and they're perpendicular.
Opposite reciprocal. Yep. All right, so this one makes you graph it first and then find the distance. So this is already in slope-intercept form. This is up 4, 1, 2, 3, right 2, or down 1, 2, 3, left 2. And there's my first line. Then this is not in slope-intercept form, so I'm going to solve for y. Negative 3x plus 2y equals negative 1. 2y equals 3x minus 1, divide by 2. And y equals 3 halves x minus 1 half. You with me so far? So what's true about the equation here? What do you notice about this equation and this equation? They're parallel. They already have the same slope. So you don't have to figure out their slopes. You already know that they're parallel, right? So now if I graph the second one, negative 1 half, up 1, 2, 3, right 2, up 1, 2, 3, right 2. And I draw my line. That's a bad one. Okay, these should be parallel. They are. Okay, so now I need to find the distance between them, which means what? I need to find a perpendicular segment. What would be perpendicular to a line that has a slope that's 3 halves?
The y-axis.
Negative 2/3. So I'm going to go from my graph, any point that's there, and see if I can find an exact point that's that. So if I start here, negative 2/3 would be down 1, 2 to the right, 3. Okay, I've gone past it. Negative 2, 1, 2, 3. I've gone past it. Negative 2, 1, 2, 3. I've gone past it, right? But if I draw lines here,
Wait, are you just going? Isn't it negative?
oops. Isn't what negative?
Like negative 2 or 3 going down.
I want negative 3, negative 2, 3. So I went down 2, but to the right 3. Right? Oh, jeez Louise. I think I shifted my points. But you can tell, right, that if I had continued this one specifically, I would have passed through this point here. Do you see that? That's a perfect point. I would not use ones that are fractions. I would find the perfect point. So I know that this is a perpendicular segment and that these are the 2 points I'm going to use to find distance. You want to find a perfect point. You probably could have also used this one too. Or this one. Okay. If this is a question on your test, I will give you a coordinate grid so you can be exact. Otherwise, if you like count your spaces, you're not going to be right. So you'll get a coordinate grid. So if I wanted to find the distance between this one, which was 0, 4, and this one, which was 3, 2, I'm going to do the square root of 3 minus 0 squared plus 2 minus 4 squared, 3 squared plus negative 2 squared, which is 9 plus 4, square root 13. So you're gonna, these already tell you the slopes because they're in the equation form. So that eliminates the step of having to figure out what's parallel. They're already telling you that they're parallel based on the equation. Then you've got to flip the slope and change the sign for its perpendicular. Then use the graph to find another point that is easy whole numbers that would give you the opportunity to find the distance.
Wait, can you go so I can see the answer?
Oh, the answer is root 13. Right, but this isn't this is an approximation. We don't want an approximation. Questions? Okay. Okay, we're going to do this quick, so pay attention and cut the talking. All right. Shh. So 3-1, I didn't write everything out for you, but a lot of it's there, okay? 3-1 says identify pairs of lines and angles. 3-1, 2, and 3 were what was on your quiz, okay? There was a lot of definitions back then, and it's been a little while since we've seen these, so these are great to review on your Quizlet, okay? But you definitely want to understand the difference between these. So parallel lines and planes and skew lines and perpendicular lines. Alternate interior angles, alternate exterior, corresponding consecutive interior, and transversal. Those were all vocab terms from the first one. So what's the difference between skew and perpendicular? Skew is not coplanar is the biggest difference. Not coplanar, right? They have to be on a different plane, but they are both, I'm sorry, not skew and perpendicular. Skew and parallel is what I meant to compare. They both don't intersect. So skew and parallel, okay? Both don't intersect, but skew lines are not coplanar. So if you have, like a box, right? We talked about this. If we were looking at the ceiling or the floor, parallel lines are going to be on the same side. So these would be parallel. If I use the top and the bottom on the back, those would be parallel because they lie on the same plane, but they don't intersect. Skew lines do not lie on the same plane, so they have to go in different directions. So if I pick this line here, right, then I can use this bottom angle because that's not going to intersect, right, and it's not on the same plane. I could use this bottom side. So it usually goes in an opposite direction. If the original is going left and right, I can't pick anything going left and right. If the original is coming forward and back, I can't pick anything that goes forward and back. So if I said this, I could also say this one that's going up and down in the back corner. I could also say this one that's going up and down in the back corner, okay? So you can see a diagram where you have to answer questions based on this. You can see true or false statements based on this. You could see sometimes, always, never based on this, okay? Dante.
Could they also be skew? Yeah, I think you drew it out.
If they're going left and right and up and down?
Yeah.
Yes. As long as it's not on the same plane. So this is not skew to this because that's intersecting. That would be perpendicular, right? So they can't intersect and they can't go in the same direction. All right, so then 3-2 started with our parallel lines. So if two lines are parallel and I have a transversal, then I establish, am I missing one? Is it on the next page? How did that get cut off? It should be consecutive interior too. Okay, there are relationship between these four special types of angles. So which of these are congruent if the lines are parallel?
The
Corresponding are congruent. Alternate interior are congruent. Alternate exterior are congruent. And consecutive interior are supplementary or add up to 180. Now these had names if you remember, right? These were called alternate interior angles what? Theorem.
alternate exterior theorem, corresponding postulate.
Good. So the postulate was the corresponding, and then everything else is the theorem. So if we are saying that these lines are parallel, so angle 1 equals angle 2, that is the corresponding angles postulate. If we are saying the lines are parallel, so angle 1 equals angle 3, that's the alternate exterior angles theorem. If we are saying that angle 2 and 4 are supplementary. That's consecutive interior angles theorem. And if we are saying 2 is congruent to, if the lines are parallel, so 2 is congruent to 5, that's the alternate interior angles theorem.
Pardon the interruption. Yudessa Zakayo.
So the type of questions that you saw in this were proofs. And also, like if there was an equation, so if there was something like x plus 3 here and 2x minus 5, you would have to set those equal to each other. If it was x plus 3 here and 2x minus 5 here, then you'd have to add those up and set them equal to 180. So some of you switch those on your quiz. Make sure you don't make that mistake again.
Can you go for like one of these things, but with like I remember on the quiz they had the shape.
If I get time to go back to it. If not, we could talk about it tomorrow. Yeah.
Consecutive adds up equal to 8.
Correct. Consecutive interior or supplementary, which is 180.
You know how like in the quiz there was like a part that was like, oh, like when you use corresponding or like alternate interior, like if I put theorem when I'm not supposed to, is that wrong?
So I didn't mark it off on the quiz, and I will mark it off on the test.
But when I know not when to.
So if you're just identifying what they are by definition, then it's just the names of them. So if these two are, like, identify what type of angle they are, their corresponding angles, their consecutive interior, no theorems, no postulates. If you're using that the lines are parallel to prove something about them, now it's the theorems and the postulates. And the other part is if you're proving the lines are parallel, this is where the converses come into play, right? So for 3-3, there was 6 ways to prove lines are parallel. If alternate interior angles are congruent, if alternate exterior angles are congruent, if corresponding angles are congruent, if consecutive interior are supplementary. And these are all the converses. So we would say the same name as before, like alternate interior angle theorem converse, alternate exterior angle theorem converse, corresponding angle postulate converse, and consecutive interior angle theorem converse. So if you're proving information about the angles, it's the original one. If you're proving the lines are parallel, it's the converse. What are the other 2 ways to prove that they're parallel? The transitive property. God bless you. Which says if 2 lines are parallel to the same line, then they are parallel. And the last one? Perpendicular. If 2 lines are perpendicular to the same line. I should add in there 2 coplanar. 2 coplanar lines are perpendicular to the same line. So 6 ways. So if you're doing a proof, let's just say you're doing a proof and the goal at the end is to prove that the lines are parallel, then you can go back to the 6 ways that you have, figure out which one works, and then make your steps go from there. If you're proving that information about angles, then you're using the original ones. Remember that we did like that class kick on these, that you have an extra practice. It's 3.2 and 3.3, and there was like 5 proofs. It's a good thing to look back on that stuff. That was in class kick, and remember from class kick you can export back to Notability so you can access it anytime. Okay, then came 3.4, which was just slopes of lines. So we kind of baby step our way back into the algebra part, right? Slope is the same thing as m, is the same thing as rise over run. And with points is y2 minus y1 over x2 minus x1. We established the relationship between parallel lines, which is what? They have what kind of slope? Same, good. And perpendicular? Opposite. Reciprocal. All right, 3, 5 was our equations of lines and graph of those equations of lines. So slope intercept was one form, which is your y equals mx plus b. Point slope is y minus y1 equals m times x minus x1. And then standard form is ax plus by equals c. And this is x must be positive. No fractions or decimals. So for these, you got all sorts of information, right? Sometimes I gave you the point, the slope, and the y-intercept, and you can plug it right into y equals mx plus b. Sometimes it was point and slope, so you had to take it and plug it back into y equals mx plus b or point slope. I could give you 2 points where you have to first find the slope, then plug a point and a slope in. Or the ones that we did just on that quiz from the homework was the equations of the lines that were parallel or perpendicular to it.
And the type is not going to be one of those for the point slope, right?
No, it won't say point slope. If it says nothing, then it's slope intercept, right? So if it doesn't say what to put it in, it's slope intercept. And then if it says standard, obviously that's where you want to get rid of your fractions and move the x to the side where it's positive.
X, 1, 2, 1.
Positive. And then came all the theorems we talked about yesterday that we just applied in the homework. If two lines intersect to form a linear pair of angles, then
The lines are parallel.
not parallel.
Perpendicular.
Good.
Oh yeah, that's the opposite.
If two lines are perpendicular, then
The lines are parallel.
they form 4 right angles, right?
Oh, we're doing these?
Yep. Yeah, that's you guys. The next one says if two sides of two adjacent acute angles are perpendicular, and this is finished with then the angles are complementary. So this means if I have two angles, like angle 1 and angle 2, and these exterior sides are perpendicular, that would add up to 90 degrees, which means 1 plus 2 would add up to 90 degrees, which would make them complementary. The next one says if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line. And the last one says, and this one has a name, lines perpendicular to a transversal theorem, says in a plane if two lines are perpendicular to the same line, then they are parallel, which we also talked about under section 2.3. Okay, remember that there's the review on Canvas. There's also an extra review in there, and then there's your Quizlet that you can study for the vocab. Have a great day.